Hi, my name is Antje. I work as a developer advocate for AI and machine learning at AWS. In this session, I want to show you how to automate your machine learning workflows with end-to-end pipelines. First of all, I want to introduce the terms pipelines and how it relates to MLOps. And I really like to classify MLOps into the 4 phases you see here. So when we're manually building, training, tuning, and deploying individual models, this is when I refer to MLOps 1.0. When we move from the individual models to building and orchestrating model pipelines, this would relate to MLOps 2.0. But we're still manually building and orchestrating those pipelines. When we're coming to MLOps 3.0, we're able to automatically run those pipelines using, for example, a GitOps trigger, meaning we can re-trigger a new pipeline execution when code changes or even new data arrives. Where we ultimately want to end up is MLOps 4.0, where we are able to use statistical triggers such as we're detecting a covariate drift or a label shift or a concept shift in the model. Or we can also check for bias metrics. And whenever we're detecting a drift in the bias metrics or in feature attributions as part of the model explainability, that could also be a trigger to retrain our model. In this session, I want to show you how you can get started with MLOps 2.0, which means building end-to-end machine learning pipelines. And then I'm also showing you how you can start implementing MLOps 3.0 and trigger a pipeline automatically with new code commits. All right, so let's get started. So I'm in my AWS environment in SageMaker Studio. And the first code example here is showing how we can leverage SageMaker pipelines to create those end-to-end ML pipelines. And as a use case, I take a fine-tuned or a pre-trained BERT model, and I'm going to fine-tune it and create a text classifier. As the dataset, I'm using the Amazon Customer Reviews dataset, which consists of over 150 million customer reviews from the Amazon.com marketplace. And you can see here it consists of a lot of information. I'm particularly interested in the review body, which contains the text of the review, and the star rating, which is my label, which is a value between 1 and 5 representing the stars for the review. So for example, if I say, I love this product, this should be classified hopefully as a 5-star rating. All right, so normally if I build manually my model, the steps would be as follows. I either pre-train a model or I use a readily available pre-trained model, which I'm going to do in this case. And I need to do some feature engineering. So in my use case, I need to convert the raw text that is coming in, the review text, into specific word embeddings, in this case, BERT embeddings that the model is expecting as input. Then I'm fine-tuning the model to my specific data set and adding a classifier layer on top to be able to predict the star ratings given any input data. All right, so let's see how we can implement this using SageMaker pipelines. Pipelines comes with a couple of components. So the pipeline overall represents a DAG, a directed acyclic graph of the individual steps to perform in the pipeline. And the steps are pretty much what you know if you have been working with Amazon SageMaker already, which is processing jobs to, for example, run the feature engineering, the training job to actually train the model. And it's also adding a couple of steps which we can use, for example, a conditional step, which will take an evaluation of the model. For example, in my case, I will calculate the confusion metrics and the accuracy. And in the conditional step, I'm going to compare this against the threshold value, which I'm specifying for the accuracy. And then if I'm meeting the threshold or exceeding it, I'll then register the model to the model registry. And if it's below the threshold, you can specify an action, for example, to raise a failure or discard the model. All right, so let's see how we can implement this for this specific BERT pipeline. So here is a sample DAG. I'm going to start with the processing. I'm going to engineer my features, taking the raw text and creating the BERT embeddings. I'm also splitting the data into a training, validation, and tests data set. And I'm creating TF records as I'm using TensorFlow as my framework. So I'm optimizing for the training step. In training, I'm then fine-tuning the model to my dataset, the Amazon customer reviews. And I'm implementing an evaluation step, which will calculate, as I said, the confusion metrics and in my case, the accuracy. Obviously, you can adopt this to calculate any metric that makes sense for your specific use case. And then the accuracy condition will evaluate the result against my defined threshold. And in case I'm meeting my accuracy level, I then register the model to model registry, and I'm also creating a model object so I can deploy it into my account. All right, so for those of you who might have not heard of the model registry, this helps us to catalog models after the training step and also gives us a nice tool to compare models and also approve the models and then deploy them from the registry into the different AWS accounts. I'm also showing you in this notebook how you can make use of SageMaker lineage to show the artifacts that are being generated in each step. All right, so let's get started with the code here. So here's another quick overview of the individual steps that we're building. And let's just jump right into it. So first of all, I'm pulling in a couple of SDKs and setting my environment variables. So I'm pulling in the session, a bucket, setting the role and the region. And I'm also getting my SageMaker client object here. Then what I'm also doing is I want to track this pipeline and the pipeline executions as SageMaker experiment. So I'm creating an experiment here. And I'm giving it the same name as the pipeline, so it's easier to compare. Creating the experiment, and then the individual trials within the experiment basically map to the pipeline execution runs. And then as part of each trial, you have trial components, and those would naturally map to the individual steps within my execution, for example, the processing step, the training step, the model register, etc. All right, and then I need to specify a couple of parameters. So for example, where to find the raw input data, which is basically in a 3 bucket in my case. You can see here I'm pulling in TSV files that are part of this Amazon customer reviews dataset for 3 categories. And the parameters you can use to parameterize the pipeline executions. So whatever you're specifying here as a parameter, you can later on dynamically pass in when you start a pipeline execution run. So it makes sense to have the hyperparameters defined here so you can change them between the different execution runs and see how the model performs. You can specify parameters as string, integers, or floats. So in my case, I'm just passing in a few of them. I'm starting with the experiment name. And for the processing step, I'm specifying the input data and the instance count and instance type for the processing job to run. And a few more that my pre-processing script, feature engineering script can handle. For example, the max sequence length, which is specific to BERT, but also whether to balance the data and the split percentages for train, validation, and test data. My script also writes the generated features into the SageMaker feature store. So I'm also passing in parameters to use the right feature group to save and store the features. All right, and obviously I need to have my pre-processing code, so you can see that in this Python script here. Okay, so with that, I can start building my processing step. And this looks pretty familiar, hopefully. So as you would specify a processing job within SageMaker, you can pull in here, for example, an sklearn processor to execute the script. And I'm defining my processing job inputs and the outputs. In this case, inputs is the raw input data. And the outputs are three different S3 locations for the resulting features, split into the training, validation, and test data. And with that, you can define the processing step, which is basically one step in my pipeline, giving it a name, pointing it to my code, the feature engineering code script, passing this sklearn processor, and all of the arguments that are needed. All right, so we got the first step going. Next, we're going to define the training step. And this looks pretty similar. So I'm starting with defining a couple of parameters, instance type and instance count for training. I'm also now listing all of my hyperparameters, which I might want to tune between the different runs. So for example, number of epochs, learning rate, epsilon value, batch sizes, etc. I have quite a few of them. And then I'm also defining metrics to track the model performance. So those are the regex expressions to scrape those metrics from the CloudWatch logs during training. And of course, my training script. So I'm running everything as script mode here, as you can see. And this is basically my model training script. And then I'm specifying the TensorFlow estimator. Again, this is similar as how you would do it with a traditional SageMaker training job. Defining my TensorFlow estimator, giving it the entry point, my training script, source directory for any requirements txt, and passing in all of the parameters. And note that for the hyperparameters, I'm referencing the parameter which I defined above. And you can specify default values, or we can pass in different values when I start the pipeline execution, as we will see here in a bit. All right, and with that, I define the official training step. And you can see here, just as a quick note, all those steps are defined in SageMaker SDK in workflow.steps. So here I'm pulling in the training step, giving it a name again, and passing the estimator and the inputs. And in the inputs, you can see that I'm relating to the previous processing step and taking the output of that step as an input here, which is the bird train S3 location, the bird validation, and the bird test. All right, and we have the training step defined. So next is the evaluation. And in the evaluation, I'm basically passing in another Python script, which in my case calculates the confusion metrics and the model accuracy. Again, you can define in here anything that makes sense to evaluate your model performance. The important step here is that you're writing the results into an evaluation JSON file. And this is called the property file, which the condition step then reads to compare the results against your threshold. So I'm doing this here. And then the evaluation step is basically implemented as a processing job. So again, I'm defining this processing step, calling it evaluate model, passing my code, and taking the model artifact as an input and the data, and then I'm writing out the metric as a result. All right, and the model metric is made up of this evaluate JSON file. All right, and next would be the condition step. But to build the condition step, we need to first have what's happening afterwards, because we're referring to those execution as possible path if I meet the condition. So let's first define what we do after the condition, which is if we're meeting the threshold, we want to register the model and then also create a model object. All right, so here I'm setting a couple of more parameters. One of them is how to approve the model. So you can set this, for example, to always be approved, or what makes much more sense, to have a pending manual approval in between. So you can actually review the model before it's available for deployment. All right, let's do this, and let's also specify a model package group where to store and register the model. And then I can define my register model step, as you can see here, passing in the estimator, the inference image URI, the S3 location from the actual model, and specifying everything needed here, for example, the model package group name, etc. And I'm also passing in here this model approval status. All right, and then I'm also creating a model as another step. So here I'm pulling in model from SageMaker, creating the model, and taking the inputs of the deployment instance type. And this is my create model step. All right, and with the basically targets in place, I can now define this condition step, which will decide whether we're going to execute those. All right, and here, as I said, I need to define a threshold value to compare against. In my case, I'm opting for a very low one. So for the minimum accuracy, I'm just setting here for demo purposes a 0.01. So every model, even with few data, will actually pass. Obviously, for your production use cases, you would definitely choose a higher value. You might want to have a threshold of 0.8 or even 0.9, depending on your use case and your models. In this case, I'm opting for one that's always going to be passed. All right, and then I can define here the comparison. So in this case, a condition greater than or equal to this minimum value. And this is going to be from my evaluation step. I'm going to take the evaluation report and compare it here to my value. And this is going to be my condition step. And if the condition is met, so if I'm past my threshold, you can see here I'm calling the register step and the create model step. In the else step, you can define any other step in case of a failure. You can end the pipeline, have a different step that is doing something else. In my case, I just do nothing. All right, and with that, we're ready to define the pipeline and start it. So I'm pulling in the pipeline object, and I'm creating the pipeline, give it a name. And as you can see here, I do have parameters, which I'm passing in, so all of the parameters that we specified. And in the steps, I'm now lining up the different pipeline steps, starting with processing, training, then the evaluation, and then the minimum accuracy condition step, which will then, in case it's positive, trigger the register model and the model create. All right, and with that, we can check the pipeline definition. And you can see here if all of the values got in correctly, and this looks good. You can see your maximum sequence length, for example, set to 64. So it's picking up all of the correct values. And those are the default values because we haven't triggered the actual execution yet. All right, and let's actually create the pipeline. So pipeline.create, giving it the role to execute. And then we can start the pipeline. And here you can see how we're passing in those parameters. So here I'm passing in the dictionary, and I can set those parameters to any values that I want to test. So in this case, I'm sticking pretty much to the ones that I specified, but you can here increase the number of epochs, increase the batch sizes, play around with the hyperparameters, etc. for each pipeline execution run. All right, and we can describe the execution, check and add steps to the experiment if we need to, and wait for the pipeline to complete. So luckily, I've run the pipeline before the session, so we can have a look at the results. So in the left menu here, I go to the menu and select pipelines. And the BERT pipeline is the one we've just executed. So here you can see the BERT pipeline. You can see the execution graph, the DAG. And you can also see all of the parameters in here. And if I click here on this individual execution run, Here you can see how the execution actually progresses through this stack. In this case, it's completed, so all of them are green. And you can click here, that one says processing, and you can see the outputs, the logs of the step, and any additional information. You can also see the specific parameters and values of this execution run. So everything ties together nicely in here. All right, what I want to show you here in the notebook as well is, for example, you can pull in here the evaluation metrics. So in this case, the model came back with an accuracy of 28%, which is okay for just a little bit of data which I passed in. And you can download the trained model, can check the signature if you want. What I want to show you here is the artifact tracking. So you can pull in Lineage Visualizer from SageMaker, and I'm listing for each execution step the artifacts. So display the vis here. And you can see here the results. So for example, for the processing step, you can see the artifacts that contributed to it, which is the data set, the image, and the produced artifacts, which are the bird train, validation, and train. So the created features. Similar for the training step, the data set contributed, and it produced the model tar as an artifact. So pretty cool. All right, and then you can double check here, add some more parameters to the experiment if you like. And what I'm also going to do here is to manually approve my model. So remember, we had it set to manual approval. So you can do this in the UI. If you go to the model registry, click the version and say approve. Or what I'm going to do here programmatically, check for the model package ARN, and then do it similarly, but just through an API call, and approve the model so it can be deployed. And then, as the deployment is not part of the pipeline, I'm doing this manually. So I'm parsing here for the model name. I'm creating an endpoint configuration. And then I'm deploying the model as a REST endpoint, so we can actually see a prediction result coming back. You can list the artifacts again if you like. And what I'm going to do is I'm creating a TensorFlow predictor. And I'm passing in a review body. So let's say this is great. And let's see what the model says. And here you can see the predicted star rating comes back as a 5 for this is great. So it's doing pretty okay. All right. So what I also want to show you as a second notebook here is how you can now take this end-to-end pipeline and automatically trigger it, for example, when new code gets committed. And you can do this with SageMaker projects. It's a very easy start if you go here to the Studio UI and click on projects. You can actually just click here, create projects, and you will see templates that set up all of the GitOps automation in your account that is needed. And you can do it for either just model deployment, for the building and training, or the combined model building, training, and model deployment. So you could select the template, and this will set up everything that's needed in your account. For the GitOps, it will create GitHub repositories in AWS Code Commit and sets up all of the automation around. So whenever you commit code to that repo, it will trigger a pipeline execution. What I've done is I've built a notebook here which is doing it programmatically again through the API. And only make sure in the beginning that you have enabled projects for your AWS account and your Studio users. And again, I'm setting up all of the SDKs. And projects is implemented as a service catalog product. So the first step here is just to create the service catalog ID and then create the project. And again, this will set up all of the automation needed and will also set up the code commit repos. I'm also, again, writing the features to the feature store. So I'm adding those IAM policies to this service catalog product user role, which gets automatically assigned. And the projects comes with a sample, so you have code already in the repo that helps you to get started. what I'm doing here, I'm stopping the sample project from executing, and I'm removing that. And then I'm cloning those code commit repos into the local environment, and then removing the sample code and copying my own pipeline code, which we just saw, into that repo. And now comes the magic. So when I do the code commit, the git push, this will trigger the pipeline execution. So I'm doing this programmatically here. And we can see this actually happening if I go to the model build pipeline. So again, this is implemented with code commit, and for the execution with code build and code pipelines. So you can see here that this is the first one that I stopped, that the model build here gets started. And we can then check here for the pipeline execution to finish. And this will basically run through the same pipeline. And I can show you the code. So I cloned the repo to my local environment here. And you can see there's a repo coming up for the model build and for the model deploy. And in this model build code repo, I have already all of the code that is needed. And you just need to really specify and modify a few files in here. So for example, in pipelines, this is where your code would go. And in the DSO AWS folder, in the pipeline.py, if I open that file, this should look very familiar to you. So this is basically the pipeline definition, which we just built manually in the first notebook. So in this case, it's wrapped into a Python file. And this one gets executed whenever I push code to those repos. So this is how the automation works. And you can specify here your Python script, so the inference script. I have my pre-process script here, the training script, etc. And then the second GitHub repo here is basically for the deploy. And this will trigger another execution of the code pipeline to then deploy the model, if it's approved, into the production environment. And this is it. So you can do here, you can approve again the model for the staging. And this is an important concept here with those projects. In this case, the example has a two-phase deployment. So the first phase really is for the data scientists to approve the model if it's meeting the threshold, and then push it maybe to a staging environment. And then you, as the MLOps engineer or DevOps engineer, can use the code pipeline to then implement a second step and a second manual approval to decide whether to deploy it into the production environment. And this is what you can see here if I click the model deploy. And then here you would have this workflow, and then this includes a manual approval to then decide whether you want to deploy it into your production environment. All right, and this concludes the demo. So I've showed you how you can start implementing end-to-end pipelines using Amazon SageMaker pipelines, and also briefly how you can leverage SageMaker projects to implement a first version of MLOps 3.0, which is automatically triggering pipeline executions on a code commit, and then moving towards the more sophisticated triggers, maybe as a next step on detecting, for example, model drift or bias drift. To wrap up, I do have a couple of more resources here for you to get started. First of all, the link to the GitHub repo, where you'll find all of the code samples I showed today. And also a link here to an upcoming O'Reilly book, which I authored together with a colleague of mine, Chris Reckley, Data Science on AWS, where we discuss data science end-to-end, how to implement projects on AWS, including how to build end-to-end continuous AI and ML pipelines. Also, a few links here to blog posts and the official SageMaker documentation for pipelines and projects. And this concludes the session. Thanks for watching.